This is Learn Fast tutorial. Let's learn together. Let's learn fast. Stoichiometry is going to be our topic for this video. The whole idea of stoichiometry is being able to predict either the number of moles, the mass, or the volume of a product from the reactant, or that of the reactants from the product. Take for instance, we have two known reactants coming together to form a certain product, but we do not know either the number of moles, the mass, or the volume of the product to be formed. So stoichiometry helps us predict these values for either the reactant or product. So in other words, stoichiometry helps us to predict the numerical relationship between reactants and products. Let's take a couple of practice problems. But before that, I need you to have these two things in mind. Firstly, the number of moles is equal to mass over molar mass. And then secondly, always balance the chemical reaction before calculation. We are going to need them pretty soon in this video. But first, practice problem. How many moles of hydrogen and nitrogen are required to produce 6 moles of ammonia gas? Before we can solve this problem, we need to write down a balanced chemical equation from which ammonia is formed. We know that hydrogen and nitrogen react together to form ammonia. Hydrogen and nitrogen also exist as diatomic molecules, which means for hydrogen, it exists as a molecule composed of 2 hydrogen atoms, and for nitrogen, it also exists as a molecule composed of 2 nitrogen atoms. If we react these two, we have ammonia as the product. Now let's balance this reaction. We have 2 atoms of hydrogen and 2 atoms of nitrogen on the reactant side, 1 atom of nitrogen and 3 atoms of hydrogen on the product side. So we need to make the number of atoms equal in both sides for each molecule. Consequently, balancing the hydrogen on both sides, we add 3 to H2, making it 6 atoms of hydrogen on the reactant side, and then 2 to the product side, making it 2 atoms of nitrogen and 6 atoms of hydrogen. Because nitrogen has the same number of atoms on both sides, the equation is balanced. To obtain the number of moles of hydrogen and nitrogen required to produce 6 moles of ammonia, we need to write down the mole ratio or the numerical relationship in this reaction. So for hydrogen, we have 3 moles. For nitrogen, we have 1 mole. And for ammonia, we have 2 moles. To obtain 6 moles of ammonia, we multiply through the mole ratio by 3, so that at the end, we have 6 moles of ammonia. After calculation, we have 9 moles of hydrogen, 3 moles of nitrogen, and 6 moles of ammonia. So to produce 6 moles of ammonia, we need to react 9 moles of hydrogen and 3 moles of nitrogen. Please note, we have to multiply through the mole ratio because we were asked to obtain the number of moles for both reactants. In a case where you are asked for part of the reactant or product, the approach will be slightly different. Let's take practice problem 2 so you understand better. How many grams of carbon dioxide is formed when 2 moles of pentane is burned in the presence of oxygen? This is a combustion reaction. Recall that combustion reaction tends to always produce carbon dioxide and water with the release of energy in the form of heat and light. That being said, we need to write down a balanced chemical reaction equation. We have pentane C5H12 reacting with oxygen molecule O2 to produce carbon dioxide CO2 and water H2O. Balancing the reaction, we have 5 carbon atoms on the reactant side. We also need to have 5 carbon atoms on the product side. So we add 5 to CO2. We have 12 hydrogen atoms on the reactant side. We also need to have 12 hydrogen atoms on the product side. So we add 6 to H2O such that the product of 6 and 2 will give us 12 hydrogen atoms on the product side. We have 2 oxygen atoms on the reactant side, but 10 oxygen atoms from carbon dioxide and 6 oxygen atoms from water. summing up to 16 oxygen atoms on the product side. So add 8 to O2 on the reactant side, such that the product of 8 and 2, which is 16, will balance up this reaction. From this question, we need to know the amount in moles of carbon dioxide produced so that we can use the relationship number of moles equals mass over molar mass in order to determine the amount in grams of carbon dioxide. From the mole ratio or numerical relationship in this reaction, 1 mole of pentane C5H12 is to 5 moles of carbon dioxide CO2. So 2 moles of pentane will be to X moles of carbon dioxide. If we cross multiply, making X the subject of the formula, after calculation, we have X to be equal to 10 moles. So for 2 moles of pentane, 10 moles of carbon dioxide is formed. Now to obtain the mass in grams of carbon dioxide, we have the number of moles of carbon dioxide to the 10 moles. The molar mass of carbon dioxide to be 44 grams per mole. Using the relationship number of moles equals mass over molar mass, cancel out the moles. After cross-multiplying, we have the mass in grams of carbon dioxide to be 440 grams. In other words, 440 grams of carbon dioxide will be formed when 2 moles of pentane is burned in the presence of oxygen. If you found this video helpful, consider subscribing, follow my page, like and share this video to your friends. If you've got any question, drop in the comment section. And please don't forget, this is Learn Fast Tutorial. We have learned together. Hope you learned fast.